Hello and welcome back. In this video, we will conduct another non-parametric hypothesis test, that is chi-square test for one sample. Chi-square test for one sample is otherwise called goodness of fit. What is the meaning of goodness of fit? Let's say we have collected 100 samples from 4 categories of professionals, and the researcher may wonder whether the 4 professional categories have got equal representation. That means whether one professional category consists of 25 samples each. That we call an ideal distribution of sample. In goodness of fit, we are examining whether the observed data coincides with the assumed data, or the observed frequency coincides with the assumed frequency coincides with assumed frequency. The assumed frequency is the hypothesis by the researcher, and the observed frequency what actually turns up from the field. And the goodness of fit, the chi-square test, is the non-parametric counterpart of t-test. We have discussed previously, there are 2 types of hypothesis test. One is parametric test, another is non-parametric test. Let me explain what each means. Parametric test means all the statistical test or hypothesis test we run on metric data. What is metric data? Please recall the 4 types of data measurement that we discussed, data scales of data we discussed earlier. Nominal scale, ordinal scale, interval scale, and ratio scale. The first 2 scales measurements belong to non-parametric or otherwise categorical segment, and the last 2, that is interval scale and ratio scale, belong to metric. So hereafter I may be mentioning metric data and non-metric data, or parametric data or non-parametric data. Here this is a non-parametric test, and what we are testing, what is the hypothesis for that? The hypothesis for goodness of fit is the theoretical frequency, observed frequency coincides with observed frequency. Let me repeat, the null hypothesis for goodness of fit is the observed frequency coincides with theoretical frequency. And I have the database here, the database titled Purpose and Duration of Visiting Internet Cafe. Here I am interested to examine one variable, that is income. Income we have collected in 5 categories. We have collected this data from 400 plus samples, and the collected income has been put into 6 different categories. As you can see here, we have 6 different categories over there. I just want to know that whether all these 6 different categories of income has got equal representation in the entire database. That I am going to look at. And what is the procedure? The procedure is, go to Analyze, the menu bar, locate it, and click on and locate the drop-down, in the drop-down menu, non-parametric test, and in non-parametric test, go to Legacy Dialogs, and from Legacy Dialogs, click on the extended one, chi-square. When we click on chi-square, we will get a window like that. In this one, we can load all variables of interest here. We will get their goodness of it. But here we are interested to examine the goodness of it only one variable, that is none other than income. So I am loading income there, test variable. Then I click on OK. Yes, I got the result. Yeah, just look at the first table. Our table of interest is second only. But the first table gives us some basic information regarding that. We have look at the second column, that is observed N. Observed N means what is the actual sample that we have got from each category across 404. And expected means it's everyone, it is 67.3. This is nothing but 404 divided by 6. So that is an ideal category. So when we have a given number of samples and a given number of frequencies, given number of categories, the expected frequency is nothing but the given number of samples divided by the given number of category. So that is why, and we are observing whether this observed frequency, the actual frequency distribution of this sample coincides or equal to the expected or theoretical frequency. And the test status is given by this table, that is chi-square is 194.099 at a degree of freedom 5 with asymptotic significance 0.000. What each means, the 194 is nothing but the estimated value, the calculated value of chi-square, and the 5 is the degree of freedom. And what is meant by this degree of freedom? This degree of freedom is nothing but n minus 1. What is the n here? The n is the number of categories here. We have 6 categories here. 6 minus 1 is 5. And what is significance? This is nothing but the significance level that we are familiar with, the metric test. And why it is asymptotic? This is nothing but non-parametric test. This indicates that this test result has come from a non-parametric test. And what does this mean? And whether we are able to retain the null hypothesis, or we are able to reject the null hypothesis with empirical proof. Let's recall what is the null hypothesis. The null hypothesis is nothing but the data are consistent with a specified distribution. What does it mean? That is, the observed frequency is equal to the theoretical frequency. And whether is it true? From this one itself we can compare. We wanted to have a 67, or we hypothesized a 67, but it's only 26 in the first category. Second one, we hypothesized a 67 and actually it's 83. Third category, we hypothesized, we assumed 67, but actually it's 129, and so forth. And we can see that in neither of these categories, no data, no segment coincides with expected frequency in this one. As per the thumb rule, at least 50% of the categories must meet this necessary condition, that is, it must be equal. But it's not equal. That is why the thumb rule is that if the significance level is less than 0.05, we can reject the null hypothesis. Let's recall what is the null hypothesis. The null hypothesis is nothing but the data fit into the theoretical frequencies, or otherwise there is consistency between observed frequency and expected frequency. From the first table itself, we got an explicit proof that the observed frequency is not equal to expected frequency. So this is the use for chi-square analysis. And this one, see, this can happen in industrial surveys and everything. See, we have collected data from the 4 segments, 4 regions, or 4 outlets. So what is and we have got around 2,000 or 4,000. Before we do for any statistical analysis, it is better to find the goodness of fit of the data. This is nothing but with respect to metric data, we are interested to know whether the data is normally distributed. This is nothing but the non-parametric counterpart of normal distribution that we examine through chi-square analysis. So let's recall what we have covered in this video. We were discussing how to what is meant by a goodness of fit, and what is the procedure of that, and how we will take a decision after obtaining the test results.